Okay, let's review. Here's a unit conversion problem. So let's do this. I'm gonna hit start inking. Okay, so we've got 4,987,000 meters, and we'll symbolize meters by a lowercase m. We're going to put that over 1 because we're going to multiply this amount. So we put it in rational form because we're going to multiply it by conversion ratios. So we want to end up with miles. So the first thing we're going to do is convert miles. We're going to convert the meters to kilometers. Okay, so we're going to have to do that first. So 1 kilometer, km, lowercase k, lowercase m, equals 1,000 meters. So we got kilometers over meters. Now note that this conversion ratio equals 1, right? 1 kilometer equals 1,000 meters. So we're not changing the value of this fraction, but we're changing its scale. So the m's cancel, and now we're in kilometers. And now we're able to use this unit here. So notice that we want to change from kilometers to miles, so we're going to put 1.609 kilometers, because we want that unit to cancel, so we're going to put it in the denominator, and we're going to put 1 mile in the numerator. So now kilometers cancel, and this equals 4,987,123 miles, that's the units, over 1,000 times 1.609. Now you can use your calculator with this. So let's get the calculator out. Actually, let me shrink this thing down a little bit so we can get the calculator in here. I'll make it a little bit smaller so we can see the whole calculator. Pull this down. Make the screen a little smaller. Okay, clear this.
You know what? Grandpa's busy. I can't show you how to use that.
4,
I
9,
can't put my
8,
mouth on that.
7,
Grandpa's making a video.
3, divided by. So I got 4,987,000 divided by, open parenthesis, 1, 1, 2, 3 times 1.609, and that equals 3,000. So it's approximately equal to 3,099 miles. I wouldn't bother with the 0.44. Okay. All right, how many pounds of peanuts costing $3 a pound should be mixed with 4 pounds of cashews, costing $4.50 a pound to obtain a mixture costing $3.50 a pound. Okay, so we're going to have prices and amounts and totals. Okay, so let's bring this down. Okay, so first price we have how many pounds, this is pounds, lbs, okay, of peanuts. Here, you know what, let's just write pounds of peanuts, like with amounts. I don't know why they have peanuts. So many kids are allergic to peanuts. We should have some other thing in here. M&Ms. Let's make it M&Ms. Pounds of M&Ms. Nobody's allergic to M&Ms. Well, except the ones with peanuts. Okay, the candy M&Ms. All right, the price is $3. Yeah. Okay, so we got how many pounds, so we'll call that X number of pounds at $3, and we're going to have 4 pounds of cashews costing $4.50 a pound. and we want to end up with a mixture that costs $3.50 a pound. And so our total pounds of M&Ms at $3.50 will be this amount plus this, X amount plus 4, so it'll be X plus 4. Okay, so how much money are we spending on the M&Ms at $3 a pound? Okay, well, we're getting X pounds at $3, so that'll be 3X. We'll write this algebraically. And how many pounds are we getting at the how much money are we spending on the 4 pounds of M&Ms that are 450 pound? Well, that'll be 4 times 450, or 18 equals 18. Okay, and then how much are we going to spend altogether? 3.5 times X plus 4. So this is going to make a fairly simple equation. So this amount of money plus this amount of money equals the total amount of money. So 3X plus 18 equals 3.5 times X plus 4. So
it made a Google story thing?
Yeah. Cool, huh?
Yeah.
So we're going to have, let's move up here, so we'll have 3X plus 18 equals 3.5X plus 3.5 times 4. 3 times 4 is 12, plus 2 is 14. So we can do this in one operation. I guess we can subtract 3X from both sides.
Yeah, it made a couple of those for me too, but I couldn't.
And we can subtract 14 from both sides. And that's going to equal 0.5x equals 4. X equals 4 divided by 0.5. So how many halves are in 4? X equals 8. Now let's check it. That's going to be 24 plus 18 is 32. And then 12 times 3.5. That doesn't work out. 24 plus 18 is 32. 8 plus 4 is 12. Let me pause this. Looks like I made a mistake. Let me check. I'm finding it. Okay, I figured out I was making a mistake in my checking. 3 times 8 is 24. Plus 18 is 42. 8 plus 4 is 12. 3 times 12 is 36. Plus half of 12 is 6. 36 plus 6 is 42. So we're okay. So x equals 8. So here's the table. Here's the equation. And we're all set. Okay. So let's go on to the next one. Magazine is on sale for 15% off the original price. Original price is $4.60. So it's new. Minus original divided by original. Okay, so original price is $4.60. Well, actually, this is going to be, we're not going to use this.
Hey, kiddo.
We're just taking off 15, so it's going to be 4.6 times 1 minus 0.5, which is 4.6 times 0.85, which equals okay. So $3.91 is the discounted price. 4.6, the original price times 0.85. $3.91. Okay, and that's it for these problems. Let me pause it here. I'll find a few more to do. Okay, let me make a problem up. Suppose you run 5 miles in 50 minutes. Walk 7 miles in, let's say 2 hours. Let's say you're a pretty fast walker. Okay. And bike 20 miles in an hour and a half, 1.5 hours. Find average miles per hour. Okay, so distance equals rate times time. Rate equals distance divided by time, solving for rate. So you're going to add up all your distances and divide by all the times in hourly form. So you got 5 plus 7 plus 20. Okay? Let's check that again. This is miles. 5 plus 7 plus 20. Okay? Now, you went in 50 minutes. Now we want to do this in terms of hours. So that's going to be 5, 6, 50 over 60, 5 6 plus 2 plus, you can just write it as 1.5 because we're going to do this on the calculator. Okay, so this is 12. 5 plus 7 is 12 plus 20 is 32. So we're going to have, let me clear this, we'll have 32 divided by the sum of the denominators. Okay, so 5 6 plus 2 plus 1.5. That's all in parentheses. Okay, 5 6 plus 2 plus 1.5. And so the average miles per hour is approximately equal to 7.38. And that's enough. Okay, so this is an extra problem that I put on here. And let me, I'm going to think of one more. Let me pause it. I'm going to think of another problem. Okay, now let's do another problem. Let me make sure this thing's running. Okay. So suppose you start out with 80 gallons of acid solution. But you want to end up with 80 gallons at 75%. So how much of 30% and how much of, and suppose you have 30% solution and 90% solution, you're going to mix them together and you want to end up with 80 gallons at 75%. Okay, so this is a little bit different type of problem. So the percentages you have are 30%, so that's 0.3, 90%, which is 0.9, and then you want to end up with 75% at 0.75. Now, here's where it's a little bit different. The amount, one of the amounts is going to be X, and since you know you're ending up with 80, then the other amount is going to be 80 minus X. So think about it. You're dividing it up into two parts. So if the unknown is X, then 80 minus X has to be the other amount of solution. So the total of the 30% is 0.3 times X, and the total for at the 90% is going to be 0.9 times 80 minus X, and the total altogether is 0.75 times 80. So the equation will be 0.3x plus 0.9 times 80 minus x equals 0.75 times 80. And you work it all out, and you get x equals 20. So you can stop the display or whatever if you need to look at this longer. And then I check it. I just plug it back in the original equation. I end up with 60 equals 60. So you would have 20 liters, or 20 gallons, I'm sorry, 20 gallons at 30%, and then 60 gallons at the 90%. Okay, I want to pause it again. I'm going to do one more type of problem. Okay, so for the last problem, let's consider a runner and a cyclist, and they start in opposite directions. Let's draw a picture of the situation. Or they could be on an oval track. So here's the runner, and here's the cyclist. Okay, so they're going in opposite directions. The runner is running at 6 miles an hour, and the cyclist is going 20 miles per hour. So let's assume they're going to maintain the same pace, which is assuming a lot. Anyway, how soon will they be 26 miles apart? So now I already made the equation, but let's just kind of write it out here. Okay. So we're going to have rate and time and distance. So the rate, we got 6. Now the time is t, and the distance for the runner is 6t. Now remember, they're going the same amount of time, so we can use the same variable for both. And then so this is the runner, and this is the bike. Okay. And here we're going to have the total. So he's going to have 20t. I'm sorry. The time for the bike is also t. The total distance for the bike is 20t. Okay. And so their totals are going to be 6t plus 20t. And that is 26 miles. Okay? So 6t plus 20t equals 26 miles. 26t equals 26. T equals 1. So in 1 hour, they will be 26 miles apart. Now, I put 52 in here. I was going to make it 52 originally, but I think that was pushing it. So 26. All right. And I get 1, and I plug it back in, and this is really a simple equation. 6 plus 20 is 26. So that's that.